Hello, in this course we will be discussing about a very important piece of electronic circuit which is called as emitter follower. What do we see here? We see a signal generator which produces a 5 volt sine wave at a frequency of 40 Hz. We have a NPN transistor and a resistor on the emitter which is used to limit the current when the transistor is turned on, so we don't make a short between the 10 volt power supply and ground, right? It is called as emitter follower because the output terminal is the emitter and not the collector, and this output terminal follows the input signal, which is the signal on the base, but the output signal is less than the input signal with one diode drop, which, as we already know, it's around 0.6 or 7 volt. So the output is a replica of the input, but 0.6 to 0.7 less positive. The first scope represents the input signal from the signal generator, and the next scope represents the output signal. Let's start the simulation and notice that the output signal contains only the positive part of the input sine wave, right? Why do you think is that so? Our sine wave is actually 10 volts peak to peak, so it goes up to positive 5 volts and after that it goes down to minus 5 volts. You can see here as well, when the color on the base is green, the voltage is positive, and when it's red, the voltage is negative. The voltage of the output signal is 4.3 volts because, as we said, there is a diode drop between the base and emitter. Unfortunately, this circuit has a deficiency, and that is the output signal cannot go more negative than 0 volt because 0 volt, which is the ground, is the lowest point in the circuit. In this case, our output signal can vary only between these two limits, which is 0 volt and 10 volts. So what can we do to solve this problem? Well, there are two possibilities. One possible solution is to add a biasing network for this transistor, which consists from these two resistors, which after all form a voltage divider, right? Since the value of these two resistors are equal, the output voltage of this voltage divider is about the half of the power supply. To be more exact, it's 4.6 volt. If the base voltage is at 4.6 volt, the emitter voltage will be with one diode drop less. So 4.6 volt minus around 0.7 volt is 3.9 volts. This means that even if the signal generator is taken out, there will be always a positive voltage on the base, which keeps the transistor in conduction mode, right? So why is this good for us? Well, we basically add together two different signals. We add the AC signal, which is our sine wave, with the DC signal. This will raise the AC voltage automatically to 3.9 volt. So the AC signal will start its journey up and down from this point and not ground like in the previous circuit. And this is exactly what we wanted, to be able to transmit our signal from one point to another without any loss of information. I forgot to mention that this capacitor here is a blocking capacitor, so it allows only the signal of interest to enter the circuit. In this case, the signal of interest is the sine wave, while any DC signal is blocked. The other possible solution, which is also widely used, is to add to the emitter a negative power supply. Now, the output signal can have any voltage between these two values, minus 10 volts and plus 10 volts. This allows us to transfer the sine wave, which can represent an audio signal or whatever information, from the base to the emitter successfully. At first glance, this circuit may appear quite thoroughly useless, until you realize that the input impedance is much larger than the output impedance. This means that the circuit requires less power from the signal source to drive a given load than would be the case if the signal source were to drive the load directly. Or a signal of some internal impedance can now drive a load of comparable or even lower impedance without loss of amplitude from the usual voltage divider effect. In other words, an emitter follower has current gain even though it has no voltage gain. It has power gain. Voltage gain isn't everything. In the next course, we will be discussing about this input and output impedance thing, so you will understand why I said that a signal that has some internal impedance can now drive a load of comparable or even lower impedance without loss of amplitude. So don't forget that all these signal generators in real world have some internal impedance, okay? In the simulator, it can be perfectly represented hooking a resistor in series with the signal generator. The output impedance of a signal generator is small, and you have to take this value in consideration, especially when you connect this part of the circuit to another circuit. And we will see why in the next course.